What's up, rock stars? This is section 1.5, day number 2. I'm graphing linear functions, and we're going to focus today on inequalities. So let's start off with a word problem. School system is buying new computers. They will buy desktop computers costing $1,000 per unit, pretty cheap, and notebook computers costing $1,200 per unit. The total cost of the computers cannot exceed $80,000. That's what they got for a budget. Write an inequality, graph it, and then if you want to do 50 of one and 25 of another, we have enough money. So, as with any word problem, I highly recommend you doing knowns and unknowns. It's so often with word problems, students just freeze, deer in the headlights, not sure what to do. But the moment you choose a letter from the alphabet to represent the thing or things that you don't know, then all of a sudden things get unlocked and they start flowing. It's like the writer's block has already been loosened up and you can do something. So the very first thing is write down your unknowns, knowns and unknowns. So X is going to represent here the number of desktop computers that you buy, and the Y is going to represent the number of notebooks. That's what we don't know. We don't know how many we're going to buy. So let's attach a letter from the alphabet to the things we don't know and the quantities we're looking to establish. I think for the sake of space, I didn't write down some of my knowns. Like I know $1,000 per unit, and I know $1,200 per unit, and cannot exceed 80,000. But once I do that, and I pull together all these things, the numbers that I just said, and the X and the Y, you can see that 1,000. This is the amount of money you're going to spend in desktops, and this is going to be the amount of money you spend in notebooks. 1,200 times Y. And when you add those up, then the total cannot exceed $80,000. It can be equal to 80,000. And it can be less than 80,000, but it can't be more than. So this is my inequality right here, and I wouldn't have done it if I hadn't been able to write down my knowns and unknowns. Don't be lazy. It actually goes faster. The whole process will go click, 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 click if you write down your knowns and unknowns. It's not really a whole lot of handwriting. So here's my inequality, and I think just to simplify things, to make the graphing easier, I'm going to divide all the terms on both sides by 1,000. And if I do that, I get regular X, 1.2Y is less than or equal to 80. That's just going to be, they're equivalent to each other. They'll produce the same graph. They'll produce the same points. It won't change the answer in any way. But if I do that, then just the calculations get a lot easier. X plus 1.2Y is less than or equal to 80x, and that's what I'm going to graph. I'm going to choose the... and you notice, you might say, Bergman, how do you graph an inequality? Well, I'm not going to teach you how to graph an inequality. We only really know how to graph an equation. So you got to graph the equation version of it. Notice this was a less than or equal to symbol, and now it's an equal to symbol. X plus 1.2y is equal to 80. So let's sub in 0 for x, and when we do, we can calculate what y should be, and we're going to sub in y. And when we do, we can calculate what x should be. And all of a sudden, we got 2 points that we can graph. This one, 80, 0, and this one, 0, 66.66666, repeating. Great, we can connect the two, and we get a line. I'm actually going to graph this as a solid line because solid lines indicate that the boundary is in, just like in a soccer game or in a field hockey game. If the ball bounces on the boundary line, then it's still considered in. Not like a basketball game. If the ball hits the boundary, and basketball courts often have really wide boundaries, but if it hits the boundary line, then it's out. At least I've never played basketball, but this is what basketball players tell me. So we've got a solid line because we want to include the boundary. The boundary is okay. If we actually spend all 80,000, if the total money adds up to exactly equal to 80,000, then we still want that to be considered a viable option, and it's allowed because you're staying within the budget. So then the next question is, how do we know which side to shade? Do we shade all these points or shade all of these points? And what does shading even mean anyway? When it comes to an inequality, we are allowed lots of different points. We can, if we want to, we could buy 0 desktops and 0 notebooks. How much we're going to spend? It's $0, and that is less than or equal to 80,000. Not exactly the best choice when you're looking to buy notebooks, but it satisfies the inequality, and it stays within the budget. You could even venture out a little bit and go, let's see, 10 of these and 10 of these, 20 of these, 20 of these here. This point right here 20, 20 would represent getting 20 desktops and 20 notebooks. And yeah, we can see we're within budget. So all of these points individually represent points that would satisfy points that have an x and a y coordinate, that when you plug in the x value and the y value, they would satisfy the budget. They'd be less than $80,000. And if you want to know which side of these you can test, what you really should do, technically, is get a test point. And often the easiest test point is 0, 0. Get a test point that's not on the boundary. So 0, 0 is not on the boundary line. We plug in 0, 0, and yes, it does satisfy the inequality. Let's even take a look. They wanted us to check to see if 50 and 25 would work. 50 desktops here plus 1.2 times 25 notebooks. Is that less than or equal to 80? Well, yeah, actually, when you multiply it out, that's 80 is less than or equal to 80. You see it's right on the boundary. This is a true statement, so therefore, this is, yes, they will have enough money. The boundary line is this right here. It's the line that separates the shaded and non-shaded regions of an inequality. So the very first step is to graph the boundary line. And that's exactly what we did with this table. If you want to graph something, you got to go equation, table, graph. And we're not trying to graph the inequality, just graph the equation version of that. Step 2, decide if the boundary is included. So if this were, because this is a less than or equal to symbol, or even if it were a greater than or equal to symbol, then it would be represented by a solid line. If they said you could not spend exactly $80,000, if the instructions in the question had said the total cost of the computers has to be less than $80,000, then you're not actually allowed to spend exactly $80,000. You got to have to spend less than that. And the way we indicate that kind of a boundary, it would be represented with a dotted line, as you can see right here. That's what that would look like. Boom, dotted. That means the boundary is not representing any solution to the inequality. Step 3, decide to shade above or below by taking a test point. 0, 0 is often easy to calculate. That's what we did here. Shade the region containing the test point if the test point satisfies the inequality. So yeah, here 0, 0 satisfies the inequality. Otherwise, and if it didn't, if this inequality had been the other way, if it was greater than or equal to, then we would shade the other region. Boom. Let's do one of these that has absolutely nothing to do with any word problems. You're just given 3x plus 4y is less than 12. Well, how do we graph that? Well, I'm not going to teach. The first step is to graph the actual equation, the version, and that would be this: 3x plus 4y equals 12. You could, if you wanted to, solve for y, get y all by itself, and then do a table. But I think what I'm going to do is just do find the x and y intercepts by plugging in 0 here and calculating 3. And then I plug in 0 here, and I'd back calculate what the x value would be. Why don't you figure out what that is right now, just to make sure you're tracking, and just so you can see if you're really understanding what you think you might understand. So after you find that, then each of these rows represents a point you can plot: 0, 3, 4, 0. And so that's what that is. So that's step 1. We graph the boundary line. We went equation, table, graph in step 1. Then we decided if the boundary is included. Let's see. This symbol means a less than symbol, meaning the boundary point is actually not going to produce solutions. The boundary line is not going to produce solutions. This boundary line, if you actually plugged in 0, 3 into here, you get 12 is less than 12, and that's a false statement. 12 is not less than 12. So we're going to say that any point that's actually on the boundary line is not a solution. And we're going to indicate that with a dotted line, as we see in the instructions here. Then, number 3, we have to decide to shade above or below by taking a test point. Often 0, 0 is an easy one to do. So you can take a test point. It doesn't have to be 0, 0, but I just like multiplying stuff by 0 because it all cancels out. So as 0, 0, it has to. The one requirement about this test point, it cannot be on the boundary line. So 0, 0 is not on the boundary line. 3 times 0 plus 4 times 0 is 0. And is that less than 12? Yeah, it is. So we are going to shade in the region that contains this test point. This test point satisfies the inequality. We tested it. And so do all of its neighbors. And so they all get shaded in.
All right, let's do some inequalities and graphing on Desmos. So here is 3x plus 4y equals 12. There. Oh, I'm going to make sure I'm signed in, and I like to do large print. Okay, 3x plus 4y equals 12. There it is. Let's change it to an inequality. I'm just going to delete this character and then type in, just right next to the M button on the keyboard, shift comma, which is less than. You could also do greater than, and here's how awesome Desmos is. You do less than and then type an equal sign right afterwards, and it turns it into an equal sign, less than or equal to. And then y is greater than x. You can see we've got shadings here. This is blue, this is red. You can long press on these and get different options for like how transparent or what color you want, which is really fun. And notice that you've got this one here is dotted and this one is solid automatically. Just one more reason why Desmos is awesome. Take care. Why don't you copy something like this onto Desmos, as always, and bring it to class. Take care.